Okay, here's warm up 5R. We're going to determine if the two triangles are congruent and state any theorems or postulates being used. So in this first problem, we've got two sets of angles that are congruent. So far we have two A's to use, but that's not enough. We need something else. And in this problem, we've got this side that's part of both triangles. And every time you have that, then you can use the reflexive property of congruence. So we can say this side is congruent to itself by reflexive. So we use the reflexive property of congruence. Okay, and then we can say that the triangles are congruent. We've got two angles and a side. I just needed to decide if that side is included or not. And it's not. The side between these two angles would be the bottom here, or the top of the triangle here. This side and this side, but that's not the side that we have congruent. We've got a non-included side congruent. So this would be AAS, angle, angle, side, triangle congruency theorem. And then my answer is yes, they are congruent. Okay, next up, let's see what we can do here. So I've got a right angle here. Hey, if this angle is 90 degrees, this angle is also going to be 90 degrees by the vertical angles theorem, and they're also congruent angles. So it doesn't really matter that they're 90 degrees. I should put 2 ticks in both of those. Those are going to be congruent by the vertical angles theorem. And then again, I've got AAS, right? Two angles and a non-included side. So here I use vertical angles theorem. Then AAS, angle, angle, side, and then that's a yes. Those are congruent. Okay. This one I've got 3 sets of angles, so you could say AAA, but that is not one of the triangle congruency theorems, because even though all the angle measures could be the same, or are the same, one of the triangles could be slightly larger than the other one, and that means this is a no, and there's no way we can find out and we can find any of the other missing sides. So that's going to be a no. Okay. This one, again, we've got this shared side. Anytime you have two triangles kind of stuck together like this, then you've got then you can use the reflexive property of congruence. So here I'm going to use reflexive property of congruence to get that shared side. And now I've got two sides and an angle. This is the included angle, right? That angle is between the two marked sides, so this would be SAS. Okay, and then my answer is yes, those are congruent triangles. Okay, all right, moving on. So here I've got, I can use the triangle angle sum theorem, which says that all 3 angles are going to add up to 180 degrees in any triangle. So I can say, okay, x plus 35 degrees plus 85 degrees is going to equal 180. Okay, I'll combine the 35 and the 85 over there to get 120. Whoops, plus 120 degrees equals 180. And then I can subtract 120 from both sides. And x is going to equal 60 degrees then. Or actually, it has the degree symbol in the picture, so I don't need the degree symbol in my answer. It's just a number that goes in there. That's a little technicality there. Okay, all right, and then next up, hey, this is a remote, these are remote interior angles, and this is an exterior angle. Hey, these two are inside the triangle, so that's why they're interior, but they're remote when I'm talking about this angle. They're the furthest angles away from that one. This would be close to that one, right? But those ones are remote because they're further away. And when this happens, your two remote interior angles, if you take the sum of those, that's going to be congruent to the exterior angle that they're remote from. So here I can say 40 plus 10x plus 5 is going to equal 17x minus 4. Okay? So on the left side, I'm going to combine the 40 and the 5. Okay, and then I want to start combining other like terms. I got these are like terms, and so are those. They're just not on the same side of the equal sign. So I think I'll start by subtracting 10x from both sides. So 45 is going to equal 7x minus 4. Oops, I'm getting off screen a little bit there. Let me zoom out a little. Okay, then I'm going to add 4 to both sides. So 49 is going to equal 7x. Oops, and I ran out of space, but the last step would be to divide both sides by 7, and then x would equal 7. 49 divided by 7 is 7. So that's what x equals. And on to the last problem. So on this last one, we do have some exterior angles in this diagram, but they're kind of irrelevant. I don't need them at all. This problem would be the same if it just looked like this. Okay, so those are red herrings. So if you look at the triangle, it's an isosceles triangle that has two congruent sides. That means the two base angles are going to be congruent. Okay, so this is the base because it's the non-congruent side of this isosceles triangle, and the base angles are the two angles that are attached to the base. So that would be this angle and this angle. So those two angles are congruent, which means I know that one is 50 degrees. And now looking at the triangle, I can say, hey, all three angles add up to 180. Okay, I'll combine those into 100. And then I'm going to subtract 100 from both sides. And x is going to equal 80. I would need the degree symbol, right, because I'm saying that this angle is 80 degrees there, and the degree symbol isn't in the diagram. Okay, and that's the end of the warm-up, and I'll see you next time.